So this is actually like the same advice that I would give someone who is new to GKE and is looking for the advice of stuff that's worth knowing about ahead of time and isn't immediately obvious. So there's two things, and these both directly answer the performance and the cost optimization half of this. So a big thing about performance is related to DNS actually. And GKE standards DNS is not optimized by default. So like it's very common for someone to just click in the GUI to make a cluster. And if they, like now autopilot's the default, but if they did a GKE standard cluster and just accepted the defaults, the kubedns is what you would get by default with node local DNS cache disabled. And there's two things that are wrong with the kubedns default. So first off, GKE for whatever reason uses kubedns backed by SkyDNS, which the entire Kubernetes community moved away from in favor of core DNS like 6 years ago. But GKE still uses SkyDNS for whatever maddening reason. And then their cluster autoscaler or their proportional autoscaler for DNS, where it scales up the number of cloud DNS replicas or kubedns replicas in proportion to the size of your cluster, it's very conservative, where it's very slow to scale those number of replicas, and it's very common that it just doesn't scale them up fast enough. And the DNS timeouts are just a very common problem among customers, where I feel like I get 2 or 3, just me, myself, like I know the other CREs get it as well, but just 2 or 3 DNS related tickets about, hey, DNS is timing out, fix it. And it's just like really annoying that that same thing, just because of dumb defaults, just keeps popping up constantly. So another thing that's interesting about it, though, is that when you're trying to, and this is where it's like, hey, you need to know about this ahead of time. When you're trying to debug the DNS problems, you see the timeout errors in your logs. So you're like, hey, we have all this great monitoring and observability. I'm going to look at the CPU and the RAM of the kubedns pods, and they're going to look great. They always look great. And it's this thing where when dealing with performance bottlenecks, CPU and RAM is not the only bottleneck that you can possibly hit. There are other bottlenecks that exist. And I'm not sure about the specific limit that gets hit, but I think it's some kind of obscure network limit, like a packet per sec limit or something, where it just kubedns will stop working, but all of the metrics will tell you that, hey, there's no reason why it should stop working, but the logs will say that it's, that you're getting timeout errors. And the reason why it's such a common problem is that if you kubeexec into a pod and you cat the ect_resolve.conf file, you'll see this mention of in.5. And what happens is whenever you make an external DNS request, a single DNS request actually generates 5 DNS requests, because it's looking at like svc cluster.local, svc cluster, svc, the namespace, the services. So it's kind of like this force multiplier, where if you curl google.com, it actually generates 5 DNS queries. And because of that force multiplier with the indots, it's not uncommon for you to overwhelm the default DNS settings with a small cluster of only 10 to 20 nodes. And you're like, why am I hitting these scale limits at 10 to 20 nodes? And it's because of those poorly optimized defaults. And then something that's not surprising but is relevant is that GKE Autopilot, which is now the default if you go make something in the GUI, has optimized defaults for DNS. And this is like the useful thing to know is you can make GKE standard work like GKE Autopilot if you're willing to put in some very minor configuration, but it's kind of this thing where it's a good idea if you do use GKE standard, which can be cheaper for larger clusters because GKE Autopilot does have like a cost overhead, is that if you're like first learning, deploy both of them side by side and then figure out what settings GKE Autopilot is using, and then just use those on GKE standard. And the two DNS settings that I tell everyone to just, hey, use these and you won't have problems because it's what GKE Autopilot uses, is turn on Cloud DNS and Node Local DNS Cache. And then a funny thing is that Node Local DNS Cache is actually using core DNS under the hood. So GKE is using core DNS finally. They're just using it in their Node Local DNS Cache only, but it's what it is. And yeah, there's actually like a lot of feature overlap between GKE standard and GKE Autopilot. And you can make a standard cluster work like an Autopilot cluster just by using the similar configuration. And then in terms of performance, as well as a cost optimization and maintainability thing, GKE Autopilot uses something called NAP, which stands for Node Auto Provisioner. And it's basically like EKS's Carpenter.sh. It's a node auto provisioner, like it's in the name, but it's got a better acronym. So although that's a GKE Autopilot feature, there's nothing actually stopping you from using it on GKE standard. And I can't tell you how many times like a customer has problems with GKE standard nodes where they're like managing 10 node pools. And I'm like, why aren't you just using these auto provision nodes? And they're like, oh, yeah, that's a good idea. We should have done that sooner. And then the other thing that's like good to know ahead of time is that there's some performance settings that you can only set at cluster creation time. And again, they're GKE Autopilot defaults. And that's why I was making the advice about just deploy an Autopilot cluster. Like if you want a standard cluster, still deploy an Autopilot cluster to see how it's configured, and then do some compare and contrast and make your standard cluster look like the Autopilot one. But two things that Autopilot uses that you can use in standard, but you can only set them at cluster creation time. So if you don't do it then, the only way to switch to it is to recreate the cluster, is enabling data plane v2, which is a GK-specific fork of Cilium CNI, which is just the most advanced CNI, the most performant. And then it has additional functionality like layer 7 firewall rules is something that it enables. And that's like firewall rules based on DNS names. And you can only get that with the data plane v2. And then the other thing is using regional clusters instead of zonal clusters. They don't cost you any extra, or at least no significant amount. I think there's like some additional network bandwidth cost, but it's very insignificant. And the SLOs go up a lot. And with GKE regional clusters, you actually have like 9 managed master nodes under the hood. It's like 3 managed master clusters that they load balance between with 1 active. So your uptime of it goes way up, and then it's free. Like they don't charge you anything extra beyond like some minuscule amount of network bandwidth. So yeah, those are the things that will help you a lot with the performance and the cost, because Node Auto Provisioner is going to make you only pay for what you're using because it's going to scale up for a right-sized node.